Okay, hello guys. So welcome to your next part of your Home 4 Physics, chapter 3. Okay, so previously you already learned about the gravitational force. Okay, meaning the formula here, F is equals to the gravitational constant multiplied to the mass of the first object, mass of the second object, divided by the r squared, whereby the r is the distance between two centers of the body. Okay, so your gravitational constant here is fixed. It doesn't matter where throughout the universe, the gravitational constant is fixed. Alright, so if you want to calculate the gravitational force of the sun, of the moon, okay, the G value will always be the same. Alright, so that is the first thing that you learn about gravitational force. Okay, so two factors that affects the gravitational force, which is your mass and also your radius or your distance. Okay, so remember, when your mass increases, your gravitational force increases. When your mass decreases, alright, based on the mathematical equation, if here decreases, here will increase. Okay, so that is the first part of the gravitational force. Alright, now next part, you are going to go into gravitational acceleration. Okay, previously during Form 3, Form 2, Form 3, we already tell you that the G value for Earth is already fixed, which is 9.81 meter per second square. Oh, my nose. Alright, so this one we tell you is already fixed. So when you do the calculation, you just substitute the value. Alright, so for now, what you're going to learn is how do we exactly get this particular value. Alright, how do we get this what they call 9.81? Okay, so you need to first learn how to derive the formula. Okay, so sad for you guys. I feel very sad for you all. You need to learn how to derive the formula. Okay, meaning that in your SPM next year, okay, there is a possibility that this particular formula will not be given in your exam. You might need to derive it on your own. Okay, because it's stated in your syllabus that you need to learn how to derive the formula. Okay, but it's not a very difficult formula to derive. So to derive the formula for the gravitational acceleration, we are going to equate two different formulas that you had learned previously. Okay, so here you are going to determine the relationship between the gravitational acceleration and also the gravitational constant. So based on the formula that you derive after this, you are going to see whether the two things are related or not. Okay, so first, let us learn how to derive the formula. Okay, you are going to derive based on these two formulas. Okay, Newton's second law of motion and the law of gravitation, which is this one. Alright, so second law of motion you learn is F equals to ma, right? Okay, but since it's about gravitational force and gravitational acceleration, so the A, we are going to change it into G. Okay, so this one is mg. Alright, whereas for this one, it will be this. Okay, F equals to the constant multiplied to the first mass, second mass, divided by r squared. Alright, so this is the two equation that you're going to use for derivation. Okay, F equals to mg, then the gravitational, universal law of gravitation. Okay, now, since these two, we are going to equate these two equations. Since F is equal to this, F is equal to this, meaning mg is also equal to this. Okay, so mg is also equals to g m1 m2. Okay, mass 1 divided by mass 2, mass 1 multiplied to mass 2 divided by your distance, your r squared. Okay, and then once you reach until this state, you are going to cancel off your mass. Okay, doesn't matter. Alright, just cancel off one of the masses. So you come to your formula for your gravitational acceleration, which is gravitational constant multiply the mass divide by distance. Okay, all right. So your G will be your gravitational acceleration. Okay, right. Remember your unit, ms -2. Right, and then your what they call capital G. This is your gravitational constant. Okay, the value is fixed. Okay, it will always be 6.67 times 10 to the power of -11. Right, km will be the mass of the object. Okay, this one must be in kg. All right, and then your r. Okay, remember is the distance between the centers. All right, of two bodies. Okay, this one must be in meter. All right, this one in kg. Okay, so this is the formula to calculate gravitational acceleration. All right, this particular equation. All right, so how do we get the G is equals to 9.81? It's actually based on this formula. Okay, later on at the bottom, I think I have one question that requires you to calculate the gravitational acceleration. All right, so this is the equation. Now here, they want you to determine the relationship between the gravitational acceleration and also the gravitational constant. Now, in terms of mathematics, all right, we always do this, right? We look at the equation and then we determine the relationship. So in the case of this one, right, if you look based on the equation itself, if let's say the value of g increases, by right, your gravitational acceleration will also increase. This is based on maths. However, in this case, okay, this is very important, all right, your g is actually not dependent on your what they call gravitational constant. Okay, so you need to remember this. All right, your what they call gravitational acceleration does not depend on the gravitational constant. Although we have a formula to show the relationship between the two, but in this case, these two are not related. And the theory and the reason is very simple. This is a constant. The value will not change. Therefore, G is not affected by gravitational constant. Okay, your gravitational acceleration does not depend on gravitational constant. Okay, so you need to remember the relationship. Okay, G is not dependent on gravitational constant. Okay, meaning this does not affect our gravitational acceleration. All right, so your factors that actually affect G or your gravitational acceleration is only two things. Okay, all right, if you look at the formula, only two will affect your gravitational acceleration. One is your mass, one is your radius or the distance. Okay, so remember these two things. Okay, the factor that affects your gravitational acceleration is your mass. All right, when mass increases, your G also increases. Okay, the bigger the mass, the greater the gravitational acceleration. Okay, and then second thing is your radius. All right, okay, or the distance between two objects. Okay, your R. All right, so when your distance between two objects increases, okay, based on the mathematical equation, if here increase, here will decrease. All right, so your gravitational acceleration will decrease. Okay, so technically this is actually equivalent to the one that you learned in the first part of the chapter 3, where mass and the distance affects the gravitational force, right? Hence, it also affects the gravitational acceleration. Okay, now important thing that I want to highlight is this one. Okay, although we have an equation to show the relationship between the two, but they are not dependent on each other. Since this one is a constant, the value will not change. Okay, so that is it. Okay, the important thing about gravitational acceleration and also your gravitational constant. Okay, so you are going to use this for your calculations later on. Alright, now, okay, so let's look at this part here. Okay, since you already know about this formula, right? Gravitational acceleration is dependent on the mass and also the radius of the distance between the two objects. Okay, centers of the object. Okay, so in this part, you are going to look at the relationship between the gravitational acceleration and then distance between the Earth. Alright, meaning the relationship between G and your R here. Okay, now for this particular part, I need you to really focus. There are two things that we need to look at. Alright, now two conditions basically. Okay, I'm going to draw a line here. Okay, so to separate. Alright, now the gravitational acceleration, as I've mentioned in the top part, it depends on your mass and also your radius, right? Or the distance. Okay, now we are going to see what happens to the gravitational acceleration in two different conditions. Okay, one is when the two objects is inside Earth. Another one is when the objects is outside of Earth. Alright, so one is inside Earth, one is outside Earth. Okay, so let's look at the first situation or the first condition here, inside Earth. Now, this is what is stated. Okay, when the distance between centers of Earth and object increases, your gravitational acceleration increases directly proportionally or linearly. Okay, meaning as the distance increases, your gravitational increases. Alright, now this part here, okay, I'm just going to like shape this part here. Alright, okay, so this part here is actually referring to inside Earth. Okay, whereas the graph here, alright, after R, this is outside Earth. Okay, meaning this one is here. Okay, and then this one after R here is this part. The graph is this part. Okay, so what does this mean? Okay, so the confusion starts at this place. Alright, now if based on our formula here, right? Okay, I just remove this first. Okay, and then based on the derivation of the formula earlier on, right? We say that when the distance increases, right? Shouldn't the gravitational decrease? I mean, the gravitational acceleration should decrease, right? Based on the formula here. But here, it's giving you a very contradicting statement. Okay, they say when the radius between the two objects increases, the G is increasing and not decreasing. So why? Okay, this is where things will be slightly confusing if you do not understand what is going on. Now, I'm just going to show you two very simple examples. Okay, now I have two objects, right? This is object A. And then this is object B. Okay, this is the first example. Second example. Okay, object A, object B. Oops, daisy. So what is the difference between the two things? Alright, what are the differences? Okay, as you can see, the two objects here, okay, object B is inside object A. It's basically like your mat, you know, your set. Okay, set B is also equal to set A, right? Okay, alright. Whereas in this case, these two bodies are separated from each other. Okay, so the theory that we learned earlier on, whereby when the distance between the center of two objects increases, gravitational acceleration also will decrease, right? Is true for this condition right here. Okay, meaning when the two objects are separated from each other. Okay, so when it's in this case, so if we take the distance between the centers of the two objects, alright, now this one, okay, this formula is true, whereby if we say the radius increases, oopsie daisy, alright, so when we say here the radius increases, okay, or the distance between the two increases, here your gravitational acceleration decreases. So this is correct. Alright, however, in this case, alright, it's slightly special. Why? Because the objects are not separated. They are together in the same, what we call circle. Okay, now when it's in this condition, we need to take into consideration the, what we call the mass of the object as well. Okay, so for outside Earth, okay, this formula is correct. So if you look at the sentence here, right, when r increases, the gravitational acceleration decreases. Okay, so meaning this part here is here. Okay, from r to 5r here, this part here, because the two objects are separated. Now, when the object is on the surface of the Earth, meaning right here, or inside Earth, let's say. Okay, meaning, let me use a brighter color. Okay, so, alright. So, if the object is inside Earth, okay, now when we say inside Earth, meaning that we are near to the core of the Earth. Okay, we are at the core of the Earth, when we say inside Earth. Okay, you need to understand that all objects on Earth, whatever humans, grass, water, whatever it is on the surface of the Earth. Okay, so we are here. You are here. Okay, there, that is you. 3 hairs. Alright, so everything that you see on Earth is actually on the surface. We are on the surface. Okay, now this one is saying inside Earth, right? Meaning as you go nearer to the core of the Earth. Okay, now based on this particular explanation, it says that when the object, okay, the distance between the object and the center of the Earth, meaning the core, if the object initially is at here, right? Okay, and then if it starts to move towards the surface of the Earth, meaning your distance increases, right, between the center of the body and also the core. Here the distance increases, therefore your G will increase. Now, why does this happen? Okay, it's because I'm going to show you the picture right here. Okay, this is the structure of your Earth. Okay, so this is your core right here. Okay, then as you go nearer to the surface of the Earth, you will notice that your gravitational acceleration is actually increasing. Okay, and then if you notice that this part, it decreases until 9.8. Okay, so in truth, the actual what you call depiction of the gravitational acceleration as you move from the core to the surface is that it will increase and then it will decrease back. However, in your syllabus, right, I think they do not want it to make it too confusing for you guys, so they are just telling you that when you move from the core until the surface of the Earth, your gravitational acceleration increases. Now, if you see here, this is 0 ms per second squared. Okay, so theoretically speaking, if your object, okay, is right in the middle of the core, okay, meaning there is no gravitational acceleration. Why? Because there is no distance, correct? Okay, so if your Earth is like this, okay, and then the center is here, right? And then the object is also right at the center. Now, during this condition, okay, your r is equal to 0 because there is no distance between the object and the center of the Earth. They are overlapping, alright? So since your r is 0, therefore your gravitational acceleration also equals to 0. Okay, so remember this, when the object is in the center of the core or in the center of the earth, your gravitational acceleration is equals to 0. Okay, so this is the first thing that you need to know. Now, so let us show you. So if I am here initially, alright, okay, and then if I slowly, okay, move towards the surface of the earth, reach here, okay, so we just ignore this part for now lah. Alright, don't look at this first. Okay, so as you travel from the core to the surface of the earth, you will notice that your gravitational acceleration is increasing. Okay, therefore the graph here or the statement here, alright, as your radius increases, your g also increases. Now, why does this happen? Because number one, okay, inside earth we need to consider the mass. Now here your core, right, okay, what happens to the density of the core? Technically here your density is actually lower, so meaning that your mass is actually smaller, right? Now whereas if you compare, let's say on the surface here, okay, this is the surface. Okay, now as you compare on the surface here, the density is actually higher compared to the core, so your mass is also higher. Okay, so now you know where I'm going, right? Because if the mass is lower, what happens to the formula here? Okay, since the mass is smaller, therefore the gravitational acceleration is smaller at this part. Whereas on the surface, because the density is higher compared to the core, the mass is also higher. Therefore, when the mass increases here, your g also increases. Okay, so this is the reason why inside Earth, okay, when you are moving from the core to the surface, meaning that the distance between the object and the center of the Earth increases, your gravitational acceleration also increases. Okay, it's because of this reason right here. Okay, so I hope that you guys can understand the meaning of this part. Alright, so to summarize the story, okay, gravitational acceleration, two different situations. Okay, one is inside Earth, one is when you are outside of your Earth. Okay, remember it must be between two objects. Now the only problem is the two objects are together in a space or the two objects are separated. Okay, now when you're inside Earth, which is this condition, okay, so maybe I can use this as your summary. So this is when inside Earth. Alright, when the object is inside Earth. So basically your R will be from here to here. This one will be the R. Okay, whereas this one is outside Earth. Okay, outside Earth is not a problem because it follows the what they call the rule that we learned earlier on, whereby when the distance between the two objects increases, your gravitational acceleration increases. Okay, whereas inside Earth is different. Alright, inside Earth, alright, when your R increases, okay, your G also increases. It will increase until the surface of the Earth. Okay, so technically, if I write it in value, here will be, oops, a lot of value here, 0. Okay, and then as the object slowly moves to the surface until it reaches the surface here, at this point here, this is where you get your gravitational acceleration. Okay, and then if the object continues to move, alright, so let's say my friend here, okay, he decides to go out from the Earth. Okay lah, jalan-jalan sampai keluar. Okay, now he is not inside the Earth anymore, right? Outside Earth. Therefore, as you're outside Earth, the theory applies. Okay, if you are further away from the Earth, the gravitational force that you experience is actually lower, right? Therefore, your gravitational acceleration will also be lower. Okay, and then if you move even further, then of course your gravitational acceleration will decrease even further. Okay, so that is the relationship between the gravitational acceleration and also the distance. Okay, so you need to know two conditions. One is when the object is inside the Earth. Okay, another one is when the object is outside of the Earth. Alright, meaning the two objects are separated. One is the two objects are together in the same place. Oh, my nose. Okay, so that is why here the graph is going up. And then here the graph is going down. Okay, so you need to know the graph. So this part here is when inside Earth. Alright, and then this part here is when outside of Earth. Okay, so just remember, when it's outside Earth, we follow the what we call the same rule as your gravitational force. Okay, when the distance increases, your gravitational acceleration will decrease. Okay, alright, so that is it. Okay, the relationship between the two objects. Okay, yay, done for this part. Okay, so I hope everyone could understand why inside Earth, as the distance between the object and the center of the Earth, meaning the core, increases, your gravitational acceleration will increase. Okay, and then remember when we say inside Earth, meaning the core, not on the surface. Alright. Okay, so this is the calculation that will involve your gravitational acceleration. Alright. So normally they will ask you to calculate the what they call gravitational acceleration of the maybe the satellite, okay, or the mass of the satellite, or so on and so forth. Okay, so the condition here is that you need to know that your satellite, as they orbit Earth, okay, you need to take into consideration the height of the satellite from the surface of the Earth. Okay, that is why I make it into like this. Okay, when the object is not on the surface of the Earth, your r squared here, you are going to change it into this one, r plus h squared. Okay, because you need to take the radius of the Earth, meaning this part, added with the height of the object from the surface of the Earth. Okay, so this is your total r when the object is not on the surface. Okay, the equation will be like this. Alright, now when the object is on the surface of the Earth, so let's say if the satellite now is on the surface of the Earth. Okay, now in this case, alright, if the object is on the surface of the Earth, okay, this one is object. Okay, when it's at the surface of the Earth, right, the distance between the object and also the radius, the center of the Earth, is equivalent to the radius of the Earth. Okay, so meaning it's at this point here. And so your r, you just take the radius of the Earth. That is why below here, they change it into capital R squared. This capital R refers to the radius of the Earth. Okay, so to make things simpler, alright, when you are not on surface, okay, your radius or your distance, you must add up the radius of Earth added with the height of the object, okay, from the surface. When the object is on Earth, okay, your distance here is equivalent to the radius of the Earth. That's it. Okay, just know how to change your formula depending on where is the position of the object. Alright, so later on at the bottom we have a few what we call questions that you can try. Alright, so spend a lot of time talking about all this, alright, because I want you to really understand, especially this part. Okay, why here the radius increase, the gravitational acceleration also increases. Okay. Next part is about this one, the importance. Okay, why do we need to know or how to calculate the gravitational acceleration? Okay, now this, to all my students, this is your homework. Alright. Okay, so you need to go out and find out. Okay, you need to do a little bit of reading. Alright, and I will discuss this during our online class next week. Okay, but to my students, alright, okay, two assignments for you guys. Alright, one is to find out the what they call information about this one. Why do we need to know gravitational acceleration on different planets? How does this help, especially the space exploration? Okay, another thing that you need to find out is this. Okay, the effects of gravity on growth of humans. Alright, so astronauts, as they go to outer space, okay, they are actually exposed to what they call health risk. Okay, meaning that they are going to experience certain amount of effects on their physiology. Okay, their density, their bone, their lungs, okay, their what they call blood circulatory system, and also their blood pressure. All right, so something will happen to the growth of humans if you stay in outer space for a long time. Okay, this is also your assignment. Okay, so you also need to find out okay, what are the effects of staying too long in outer space, all right, on the growth of humans. Okay, there are tons of resources that explain about the effect on the what we call growth of humans based on here. All right, so I'm just going to give you one example. Okay, let's say the height. Okay, this one for those who are very short is a good news for you. Okay, why? When you are on Earth, this one maybe is your height. Ding ding. But when you are in outer space, what will happen to your height? For those who are short, ha 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 ha, congrats. You might get taller. Dun, 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 dun. Yay. Okay, but why? Okay, so technically it's because it's like this. When you are on Earth, right, you have gravity pulling, right? So when your gravity pulls you downwards, okay, they pull you downwards, all right. Therefore, your what they call basically your bones cannot actually grow more than what is expected lah. Okay, the basic concept is like that. But when you're outer space, because the gravity is not that strong, so your bones will actually elongate more compared to on Earth. But this is only when you are in space for a very long time, and of course it doesn't what they call suddenly elongate that you become like Jack the Beanstalk, something like that. No. Okay, your height will increase by a few centimeters, not by a few meters. Okay, you don't go to outer space, come back, and then you become like an alien. All right. And if you look at the story of the alien, right, the people who draw the alien are long aliens, correct? And there's a reason why they draw it so, because maybe the aliens from the outer space, their gravity is not as high compared to Earth, right? So they are able to grow taller. Okay, that is why all the depiction shows that the aliens are tall and long. Okay, all right. So these are the two what they call assignments that you need to do for now. All right. So I'm going to stop here first. Okay, before I go into the centripetal force. All right. I want you to digest the information here first. Okay, then only I go into the centripetal force. Okay, so that is it for now, and I will continue in the centripetal force in the next video. Okay, bye. Oh.